Okay.
Right. Sure. My name is Janosch Oppermann. I'm a software programmer by trade. And since, I think, I'm not even sure, like 2.5 years or something, I co-founded a business which is called Clipper Automotive. And what we're doing is we're building electric cars. And our initial focus is the London Black Cab. And essentially, if we go to the next slide. Yeah. So the motivation, I'm not sure. Well, first of all, maybe if any of you guys drive electric cars or you're into electric cars, maybe you want to put that into the chat. Would be quite interesting. My understanding is there's about 38 people listening to me now. And presumably most of you are London-based, so I wouldn't be surprised if many of you don't drive. Maybe you have a Zoe, someone has a Zoe or a Leaf or a Tesla or something, or 6 years, that's great. So the problem that we're addressing is that taxi drivers drive between 120, 140 miles diesel propelled in central London, even though the technology is around. The problem, and then there's only three different manufacturers for taxis. There's LTI, which has gone bust, which is now called LEVC. And then there's Mercedes, which has got the Vito. And the third one is the Dynamo van. And there was this backstory with Metro Cab as well. The story about the new cab, and this is what personally annoyed me, and I didn't even knew about this. LEVC stands for London Electric Vehicle Company, and they are right in that the propulsion is electric. However, they have what they call a range extender, which is 1.6 litre petrol engine. And what they've done is, well, actually, I have to be a bit careful here about libel, but what you will find is, if you look at one of these vehicles, it's very hard to spot the exhaust, but they still have the exhaust at the bottom. So, in my opinion, what they're doing is they're selling drivers a hybrid, and that doesn't go far enough. So. And then the other one is, if you've read the slides, if you read the slide while I spoke, they're charging them an absolute arm and a leg. They're charging them 70,000 pounds, yeah. And the drivers, and what the drivers do, especially because they've now also been battered by COVID, they drive their diesel as long as they can, because it makes financial sense to them. So what we're trying to do is we're trying to give them an alternative option that preserves the look and feel of the cab, but makes it all electric. And if you look at the top right of this slide, that's one of our examples that lives and works in, well, that photograph is in. Actually, this is a question. Who can tell where that photograph was taken? And the put it in the chat. And then our approach is, we're taking stuff that's there and adapting it. We used to say adapting it for the 21st century, and we don't believe in hybrids or anything, so we just made it all electric. Do you know what Westminster Abbey is called in cabby language? It's not in London. I wouldn't know. Maybe Parliament Square. Anyway, that's right. That's Bristol Cathedral. So anyway, so what we? Oh, does it? I didn't know it said it in the photo. Okay, fair enough. All right. Do you want to progress one slide?
Yeah.
There we go. Yeah, here's some. I guess those are just some more impressions of a workshop and all that. So we've built multiple vehicles. They're all identical. That's me soldering at the top. That's my business partner at the bottom. Just go to the next slide. Yeah. So what we did is we put a 40 kilowatt hour battery pack in it. There's an 80 kilowatt motor and a 10 kilowatt AC charger. Usually that's limited by the grid in the UK to 7.7. So this is for home charging. And additionally, there's 50 kilowatt rapid charging. And what we've done with these production vehicles is we retain a bunch of comfort features. So you've got power steering. The cockpit for the driver is essentially exactly the same as before. We're repurposing, like literally repurposing the dials on the dashboard. And if you go off the figure of the £70,000 for a brand new LEVC, we can do this 42% cheaper. Although they're not quite for sale, we're leasing them out on a weekly basis to drivers, which is fairly common anyway. If you guys want to see the car move, if you click on that thumbnail there, it should open the video on YouTube. If that's too complicated, we can just skip. I'm not sure if the slides are shown. Oh yeah, there we go. There's no sound in it, so I can just waffle over it. For rainbow. Anyway, so I'm not sure. It doesn't really work in Zoom, I suppose, right? Anyway, you have to take my word for it. They drive. And all the modifications that we've done to the exterior of the vehicle is we've sealed off the fuel filler cap, actually, and we added a charge port in the front. And then now I'm just going to give you a high-level overview of how the system is put together, and maybe some guidelines that we followed. So if you just want to go to the next slide, sorry about this. This is like a high level overview of what we're doing. We take the diesel motor out. We take the fuel tank out. We take the exhaust pipe out, of course. And then on the lower left-hand side, this is what you guys are probably going to be interested in. That's the vehicle control unit. I'm going to get into that in more detail later. On the top right-hand side, you can see B1 and B2 are the battery packs. So we've got a half of the pack is in the front, half of the pack is in the rear. M is where the motor is, G is where the gearbox is. You can see in the bottom two right pictures, we had to make a gearbox adaptation, where we had to match the drivetrain. So the motor and the gearbox, the motor and the inverter are from a Nissan Leaf, and we needed to match it to the taxi drivetrain. The taxi is a front motor, rear wheel drive car. Nissan Leaf is a front motor, front wheel drive car. So you have to do a bunch of gearbox adaptations there, which all of it we've done. Someone just said we should hide the charge port. We could do. I quite like having something that's almost the same, and then you've got a subtle difference that makes you go, what's going on here? Also, just to be pragmatic, it was the easiest place to put the charge port. If you want to go to the actually no, stay on this for just for a second. So in the lower left hand side, you can see the vehicle control unit. The red board we buy off the shelf. That's an STM32F103 microprocessor on it, and then everything that's green I've drawn in KiCad and pre-populated. It's essentially an adapter board that goes straight where the VCU is. It goes in a 3D printed case. If you would like to go to the next slide, please. System design. So essentially, top right-hand side, you can read that white box yourself. There's a Raspberry Pi in here, exactly, which we're using for monitoring of the traffic. We've met many people who speak about retrofitting electric components into cars. And there's quite a few who actually went all the way to the IPO, like I think it's Arrival, Neo, Rivian, and quite a few of them haven't been able to produce working cars yet. What we've done is we stand on the shoulders of giants. We take stuff from existing EVs and some own developed components to put them into an existing vehicles, which is why we were able to produce multiple working vehicles within. The first prototype, which is now scrapped because we built it kind of wrong, after I think a year and a half, and then the other two another year and a half. So very important to lean on existing components. There's no point in reinventing the wheel. We're leaning on open source and open hardware as well. There's 2 GitHub repositories which are incredible. There's Damien McGuire and Johannes Hübner. And what they do is they take originally manufactured EV components, reverse engineer them, and put their own logic boards in it, so you're able to use them in your EV conversion, and we're one of the people using them. Developing our own components where needed. Very important. You've seen the circuit boards that I designed there. I only do that when I can't possibly find something else that works for our purpose. The nice thing about the printer board there was it fits right where the previous engine control unit was. There was an original taxi connector on the top there. We're reusing as much from the taxi as possible. If I were to do another vehicle, I would do exactly the same. And fast iteration, I guess we focus really hard on having always cars that drive and that charge ready, and we try to iterate fast in small steps. We're pro-regulation. Whenever someone asks us, oh, this is really safe or whatnot, we go, okay, how can we prove to you that it's safe? They give us an answer, and then we just do the test. So IVA is an individual vehicle approval. They are inspected for electrical safety because we're dealing with high voltage here. Yeah, do you want to go to the next slide, please? I think we're almost at the end, actually. I'm open for questions. Oh, STM32. I think this slide says it. Maybe not. Maybe it's on the software side. Okay, so it's a backpack design. I've already said that. Yeah, and then what we initially did, we took a whole Nissan Leaf and experimented with it. And we thought, or we imagined it initially, that it would be like an onion where we shave bits of the system off until it fits. From my experience or with our knowledge, it was more like an egg or like a coconut. You crack the system at some point, and then you're left with a bunch of shells, and you're trying to reglue them together to do what you want, and then the onion approach didn't quite work. So that's essentially what the VCU is doing. It's orchestrating components from. At the moment, we've got a Tesla component in there. 2 Tesla components in there. We've got Nissan Leaf components in there. And we've got taxi components. The taxi is pretty dumb in a way. It doesn't even have a CAN bus, or at least it's not exposed. There's some internal protocols that talk to each other. That taxi, we're using essentially discrete digital inputs, i.e., steering wheel inputs, shifter, throttle input, brake, that kind of stuff. Yes, if we're going to go to the next one. Oh, well, no, we've got a CAN bus for ourselves. How does that work? We've got a CAN bus for our components. Right. The VCU controls the inverter. The inverter turns the DC from the battery into AC that actually drives the 3-phase AC motor. That's done by a CAN. The BMS, the battery management system, I'm not sure how much you guys know about lithium batteries. If you've got a whole bunch of lithium batteries, you want to make sure they're all balanced with each other. There's the battery management system that A, does that, and B, tells you if something is wrong. It gives you safety limits that are given to us via CAN as well. If a limit is exceeded, essentially you turn the car off because it's not safe to drive. The charger also speaks CAN with us, and then vehicle signals, key shift is the key turn, shifter pedals, etc. Software, as someone asked earlier, what operating system we're using, the answer is none. We're using libopencm3 as a library, and it's bare metal C++. It's one while loop and a bunch of interrupts. I rely really heavily on unit tests. Essentially, I'm a test-driven developer for this. I implemented a state machine to where the vehicles to model the vehicle state, i.e., I'm in state charge, I'm in state drive, I'm in transitionary state, etc., etc. And there's if you go back to the GitHub, not now, but like later on, there's an web interface for the ESP8266, which enables me to see parameters as we're driving. And now we're coming finally to the Raspberry Pi. The whole CAN traffic, I've got a device which I call the flight recorder, which essentially is a Raspberry Pi with a Pi CAN, which is on the CAN bus, and it just dumps all the CAN messages into a log file while driving. It's not always in the car, but whenever we're trying new parameters or something. I think that's the end. What's the next slide? Yeah. Oh, so initially we put some money down ourselves and built the very first prototype. We've then been supported by Innovate UK through the New Computer Network. Yeah. Any questions? I hope there are many. This has just been a very, very high level overview. Yeah.
Can I ask an audio question? Yeah, may I ask an audio question here?
Sure.
Yeah, go ahead.
Oh, okay, good. Hey, so I'm kind of curious about what batteries you're using, and the BMS and stuff,
Yep.
and how long it's typically taking you to recharge, because this is what do you guys call them, black car, town car? How long it takes you to recharge?
Yeah. Essentially, in the current generation, the batteries in the BMS is from the Nissan Leaf. It's from the 40 kilowatt hour Leaf. So they're lithium-ion batteries. They're pouches. I should have included a photograph. The pouches is the same configuration. We've got some ideas about other cells that we could use. Essentially, batteries as well, because the chemistry gets quite hairy quite quickly, and if you combine new cells with a new BMS, you need to get a whole bunch of new certification. If you use existing vehicle manufacturers' parts together, you can say, oh, this should carry over, i.e. the combination of the BMS and the cells is quite critical that that goes right. What? Otherwise, it's a fire hazard. You might be
the reason I'm going to throw a suggestion your way.
Yep.
I've done a little bit of work on things like this. There's some interesting work out there now with supercapacitors.
Oh yeah.
In particular, there's a company called Energy. You might want to take a look at them. They are building golf carts and rickshaws with a supercap system with their own BMS. And I think they were looking for people to add on to this. But it sounds to me like in the case of recharging, particularly with a black car, you need the ability to get that car back out there again. And so there's an opportunity there. The other, so just maybe look them up if you get a chance. Enervolt. I'll paste it in. It's just a by and by. Maybe this is interesting. The other question I have is, I know UK has a big problem with its infrastructure in terms of power distribution these days, and I've been, a lot of that's politics. But how do you think this plays into your product? Is this getting to be a problem for you in terms of
charging infrastructure?
Say again.
Are you talking about charging infrastructure, or what the grid can deliver?
Yeah, what the grid can deliver, because I'm seeing this problem in the U.S. Okay, I'm seeing it in places like where I'm in Oregon right now, and there was a lot of folks who went out and even Silicon Valley. There are a lot of folks who went out and got themselves electric cars, and now they're starting to see a little bit of trouble. On loading the grid.
Yeah.
Tell me how you think.
First of all, we have 50 kilowatt rapid charging. I'm not sure if I said that earlier properly. That was that's like 20 to 80% in I think like 40 minutes or something. So if the driver plugs it in at lunchtime, and we've talked to drivers as well, 120 miles is what they drive, which is pretty much like if you go all the way from one end to the other, it's what we can deliver at the moment. In terms of the grid, I've got absolutely no idea. Making cars is pretty hard, and I'm pretty, well, one of my approaches is I put the blinkers on, just on the problem that's in front of me. My business partner is a little bit more visionary and stuff, but what we've both agreed is we're just going to focus on cars, and not even any cars. We're just focusing on black caps. So in terms of grid, I'm not quite sure. My understanding is that the government has released another 500 million or something in funding to put more chargers onto Britain's streets, and just from there's so many companies installing these at the moment. So I think it's going to change very rapidly, very soon. And one more thing to consider about cabs specifically, they don't really leave the city. Sure, sometimes or they do airport runs and stuff. The sweet spot for us is for the cabbie who's in a big metropolis and who spends a lot of time in the city center, especially because we've got regenerative braking where you can recoup a bunch of energy at every light. You can actually get really nice range out of these. More questions?
I was just going to add on to that, the National Grid in the UK has done a number of publications about capacity and being able to support EVs, and they pretty much say there is no problem. We can do this. There's obviously work to be done in certain areas, but the UK power grid is actually very fairly well designed. It's got some challenges with the switch to renewables, but it's in a far better state than a lot of the US, just because of the way the grid is designed and operates. So typically we don't see, I mean, like if I think back over the past 5 years, I think I've had 2 or 3 power cuts of about sort of 5 seconds in that time. Whereas in the US, obviously, you've got far greater distance between everyone, a lot more overhead lines. UK has a lot of buried power lines. So we tend not to have such extreme weather events. So a lot of the challenges that the US have, getting the power around over the vast distance, we don't have because far denser in population. And EVs in general, there is definitely a lot of work being done. One of the things that I've seen that, again, it gets misconstrued in the press is around smart charging and the way that the grid can communicate with the charger and tell the chargers, please back off because the grid's under load at the moment. Mm-hmm. And it will back off for the half hour or an hour, during peak demand. And then at other times when there's sort of a lot of excess capacity, you can just go, EVs, fill your boots. We want you to charge up as much as possible right now because there's lots of spare capacity. So there's effectively two different levers that can be pulled, one to back them off and one to encourage them to charge. And those two things together really help balance the grid.
There was a question about storage, which I'm not quite sure understood. For the Raspberry Pi, there's just the standard SD card in it. There's nothing special. The grid. I'm sure there's problems and all that, teething problems. You knew a lot more than I did already. My understanding is that other people are working quite hard on that. Turns out making cars is really we had all these great ideas of we're going to do scooters and we're going to do motorcycles and all that. And we've seen other people who retrofitted cars and who do one different car every time. So they do Jag and then do a Range Rover and then they do the other thing. They really struggle with the complexity because it has to be different. The vehicle systems are different every time. The thing about cabs is they're cookie cutter, right? So if you do one, you can do with an asterisk, you can do any of them, which is kind of what why we're so relentless in focusing on just one vehicle type.
What do you do for heating and stuff like that? Like, do you have electric heating as well that you had to?
In the vehicle, yeah. but it's gonna reduce your range rate because there's only 40 kilowatts in the 40 kilowatt hours in the battery, and if we think a little bit of physics, making light is really cheap. Moving the car isn't actually. I mean, sure, it takes a lot of energy, but heating stuff up really takes a lot of energy. What they should have really is a heat pump, which we haven't got yet. But 2023 is coming. So, any more questions?
So there's a question from Vinny about storage. Tesla having problems with.
Yeah, I'll say it briefly. So Tesla had a huge problem with recalls. Apparently, they were using SSD devices for their storage, and they were logging, or their Unix or Linux variation was logging a ton of data, and they actually burned out the SSD devices. So, just FYI. And it was a minor thing. One of the programmers forgot about that they were doing this excessive logging.
Yeah.
So that's just, it's one of those. Oh, let's go back and look.
The what I call the flight recorder is a completely separate device to the VCU, right? So it wouldn't really matter. It would be a shame if we lost their data, but it wouldn't affect the functionality of the vehicle, if that makes sense.
Yeah, sure. As long as it doesn't shut you down. What you're doing is really cool, by the way, and I think it's exactly the appropriate use for those kind of vehicles. It's awesome. There's another fella. He's been floating around YouTube. His name is Super Fast Matt, and interesting cat. And so he converted a early Jaguar, using a Tesla motor. And it's fascinating to hear his problems, and how he's tried to hook up various things and the batteries and whatever. But and of course the steering. So it was cool using those parts. The Leaf motor is a good call on your part. It's cheap enough and it'll work really well.
These are workhorses. Good job. Right? Thank you very much. These are workhorses, right? They're not performance vehicles. We have looked into the Toyota transaxle as well from the Prius, because you can buy like a written off Prius. Well, not even a written off, just an old Prius. You can buy it for like $1,000 or something, and you've got an inverter, charger, and a drivetrain in there really, and you just combine it with batteries that you get elsewhere, right? The key driver for cost is batteries, but their prices have been plummeting. So I'm quite optimistic for the future. And in terms of SSDs and stuff overheating, I think I teased it earlier. I just said our price will be 42% lower, but they're not really for sale. What we're doing is we're renting them out on a weekly basis, because the rest of the year and next year is going to be about scaling up and about reliability. We're not gonna, because for the drivers it's their livelihood, right? We've driven a couple thousand miles in these ourselves, like to and from testing stations and God knows what. But for driver, very, very quickly, they rack up loads and loads of miles. So we're going to find problems really fast. And then if you sell someone a vehicle, that's quite a challenging position for them, especially if they need it every day. So if we're leasing it to them, we just give them one of the spares, right? Just, you had a problem with the cab, really sorry, here, take another one. In the same way that like a boat rental company in Greece would do it, or as a matter of fact, as the existing fleet operators do it already. That's essentially the business model in a nutshell. Just if my email address is on the website, on the slide on the screen right now, yeah? Janosch@clipper.cap, not .com, clipper.cap. If you guys have any comments or something, please feel free to drop me an email. If you've got anything, we were looking for electrical engineering talent. We kind of have that covered now, but if you know someone, especially London-based, super interesting for us. If you're interested to invest, also drop me an email. There might be a last opportunity this year before we take a bigger raise. Are there more questions? Otherwise, I would conclude it.
I think that's good. Thanks very much. That was very interesting.
Good.
Really enjoyed that.
I hope you enjoyed it. Yeah, I hope you enjoyed it.
Yeah, very good.
Thank you.
Well, thank you. Thanks for listening to me.
We could talk for hours about this one.
Yeah, maybe we will.
Thanks very much.
All right.
Okay, so we'll take a short break. We'll start. We're starting at 21:20. I'm just going to give you an update on my London Ground tube map project, which is pretty simple, but just give you an update on that in 9 minutes. See everyone in a bit. Just grab a beer or whatever.
Are people able to unmute themselves now, Richard?
Yep. Sorry about earlier.
I was curious about the energy problems in UK because I've been reading a lot about just the power, the cost of purchasing power, and how maybe they jumped over to green a little quicker than they needed to. But we're seeing a number of these issues in various states that have done the same thing, particularly high density states. And just curious, like if how the fuel prices are affecting. It's just the timing of a business. But yeah, good call.
The actual challenge with the market we have here is there's probably several factors. One is the government took a stance. There's a very famous quote of the Prime Minister a decade ago saying, "Let's get rid of this green crap," and he basically put blockers up against all sorts of renewable deployments. So it massively slowed down the deployment of wind farms across the UK, and a lot of other sort of energy saving measures. So all the funding was taken away for insulation deployment and various things. So the end result is that we've made very little progress over the past 10 years on that compared to where we could have been. There's still been a lot of progress on offshore wind, and we've done pretty well there. But at the same time, there's a lot that could have been done onshore and just to reduce energy demand. And then the other bit is the way the wholesale market is structured. So what happens is, let's say, for example, you've got you've got a certain amount of demand, and different energy companies can bid to fulfill that demand. So you might have your wind turbines go, well, we can provide this amount of energy for 10p a kilowatt hour, and the gas companies, gas generators go, well, we can provide this amount for 40p a kilowatt hour. If they take the cheapest ones, but the price gets set at the most expensive one that wins. So in other words, if part of the demand can be met by wind and part of the demand is met by gas that set a price of 40p, then actually across those two, they all get paid that 40p, which means we end up with a very expensive consumer cost as a result. And it's simply down to the way the engine...
Oh, I understand. I understand this model. Yeah, unfortunate.
Yeah, and that's led to an awful lot of pain here, where we're seeing sort of energy prices sort of double. My personal, like at my house, we were paying 14p a kilowatt hour this time last year, and now we are on 31p a kilowatt hour. That's our daytime rate. Incidentally, we have a nighttime rate, so we get an off-peak. Yeah. Off-peak rate, but even that went from 5p to 7.5p.
Wow.
For the off-peak.
No kidding.
So, yeah, it's all gone up a lot.
Yeah, we're seeing, this problem. They didn't quite think it through where we are. And we're starting to see a bunch of these little. But what's fascinating is there's a lot of folks out here, they're like, oh, I want my electric car. And I'm like, well, we're going to have to run some new power lines. and they're all like, no, we can't have power lines in our neighborhood. It's like, well, look, what do you want? You know, it's like,
well, I mean, in most cases, there's a very interesting graph that I saw that was produced by I think it might be National Grid, quite a number of years ago now. And what it showed was the kind of the sag in demand that you'd see overnight. So the graph, sort of around sort of midnight, you'd see this massive slope off of power demand across the country, and it would then start going back up again, sort of about 4 or 5 a.m. And the taper would start, say, about 10 p.m. and just drop from there. But that kind of bottom out of the graph, if you were to fill all of that in back up to the top peak demand, and look at the amount of energy that would be delivered in that time period, it very roughly worked out to the amount of power needed to deliver all of the mileage.
Oh, I see. Sure, naturally
on the road.
Yeah.
So actually, the grid capacity, if everybody charged in that off-peak period, would be sufficient to actually provide all of the transportation needs. And what's also interesting about that was the overall so I lost my thread now. The overall capacity basically pretty much was spot on, so we wouldn't need to deploy sort of lots of new infrastructure. And that was it. Also, if you look at UK demand, UK's power demands have dropped year on year for the last 20 years, I think. I think the only anomalies you've got is the old 2019, 2020, 2021, where everything obviously